Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2019, 10B Problem 15, and it deals with geometry. I hope you guys enjoy this video and let's get started. The problem states right triangles T1 and T2 have areas of 1 and 2 respectively. A side of T1 is congruent to a side of T2 and a different side of T1 is congruent to a different side of T2. What is the square root of the product of the lengths of the third side of T1 and T2? So we have two different right triangles, and keep in mind that they have different areas. So one is smaller and one is greater. So T1 is smaller, so I'm just going to let it be this one. This is T1. And then we have another one that's a lot bigger. I'm going to let this be T2. So the only possible way for all of these circumstances to happen is, well, I'm going to first let X be the shorter leg of T2. So I'm just going to let this be X. Well, because T2 has a greater area than T1, that means that the shorter side of T2, which is X, that has to be congruent to the longer leg of T1. So this is also X. And then I'm going to let the other leg of T2, so the longer leg, I'm going to let that be Y. And the only way for this to happen is when Y is the hypotenuse of T1, because the longest side for a right triangle would be the hypotenuse. And since T2 has a greater area than T1, that means that the longer leg has to equal to the longest side of T1. Well, since these are all right triangles, then basically what we're trying to find is the square of the product of the lengths of the other two sides of T1 and T2. So the length of the hypotenuse for T2, this would be, we can use the Pythagorean theorem to get the square root of x squared plus y squared. And then for this, which is the shorter leg of T1, we can also use the Pythagorean theorem to get the square root of y squared minus x squared. So basically what we're trying to find is the square of the product. So x squared plus y squared times the square root of y squared minus x squared. So that's the product, and we're trying to find the square of this. Okay, so to do this, I'm going to multiply what's in the square first, and that is just the square root of y to the fourth minus x to the fourth. And then this squared to get just y to the fourth minus x to the fourth. So basically that is what we're trying to find. Well, we can now use the areas that we're given, which is that T1 has area of 1, T2 has area of 2. Well, if T1 has an area of 1, that means that the base times the height divided by 2 is 1. Well, the base would be this, and we know that that is the square root of y squared minus x squared times the height, which is x, divided by 2. This is equal to 1. And then for this is easy for T2. It's just x times y divided by 2 is equal to 2. So that means that x times y is 4. And then I'm going to simplify this side as well, T1, to get x times the square root of y squared minus x squared is equal to 2. Okay, so this is what the first equation simplifies down to. Well, we see it's x squared times y squared. Well, we know that x times y is 4. So x squared times y squared is just 4 squared, which is 16. So we can plug that in. 16 minus x to the fourth equals 4. That means that x to the fourth is equal to 12. So we know what x to the fourth is. Well, we now want to figure out what y to the fourth is. Well, I'm going to use this equation here, which was x times y is equal to 4, and I'm going to get y, which is equal to 4 divided by x. We got that from here. And then I'm just going to raise this to the fourth power to get y to the fourth is equal to 4 to the fourth, which is 256, divided by, well, we already know that x to the fourth is 12. So that simplifies down to 64 over 3. So basically, what we get is y to the fourth is 64 over 3 minus x to the fourth, which is 12. And this would give us 28 over 3. So the answer is A, 28 over 3.